We will go to the next question, which is 6 in the series. Illustrate with a suitable example what is meant by a stereoselective reaction and a stereospecific reaction. This is important because stereoselective and stereospecific reactions form a very important part of olefin and acetylenic chemistry. Therefore, we should know what is meant by a stereoselective reaction and what is meant by a stereospecific reaction. We will take up one by one. First one is a reaction is said to be stereoselective when it gives two different products from the same starting material. As for example, we will take this CH3 C triple bond C. This is actually 2-butane. This is 4-carbon system containing an acetylenic bond between 2 and 3 carbon atoms. The starting material is the same. Now reduce this with hydrogen over palladium or calcium carbonate or palladium sulfate as a catalyst. This is known as Lindlar catalyst. This is popularly known as Lindlar. Commonly, this is known as Lindlar catalyst. The advantage of this reduction is normally whenever any reduction proceeds, it goes up to when acetylene is totally reduced with hydrogen over platinum or hydrogen over nickel, it will lead to the formation of butane. But the advantage of this reducing agent is the reduction stops at the aldehyde, reduction stops at the olefinic stage. Acetylene becomes an olefin and it stops at the olefinic stage. And particularly when we use the Lindlar catalyst, it leads to the formation of cis-2-butene. These two hydrogen atoms are there. This is cis-2-butene. Now take the same starting material and reduce it with sodium or lithium or liquid ammonia. This is also a reducing agent, but it's a different type of reducing agent. Here also the reduction is highly selective and the triple bond gets stopped. The reduction gets stopped at the double bond, giving rise, however, to a trans olefin. This is a classical and typical example of what is known as a stereoselective reaction. A stereoselective reaction is one in which the same starting material is used, two different reagents are used and two different isomeric products. These two are isomers. This is cis and this is actually trans. Trans is one in which the two similar groups are on the opposite side. So two different stereochemical products are obtained from the same starting material using two different reagents. This is referred as a stereoselective reaction. Now let us go to the next reaction. What is meant by stereospecific reaction? A stereospecific reaction is one in which we start with two different starting material. Here the starting material is common in the case of stereoselective reaction. In stereospecific reaction, you start with, as for example, you start with cis, this is actually cis-2-butene. Cis-2-butene. Now treat this with bromination. I mean, subject this to bromination. Treat this with bromine. It will form 2,3-dibromobutane. 2,3-dibromobutane will be, it will be like, it will be a racemic mixture. These two are mirror images. Actually, cis-2-butene on reaction with bromine will produce 2,3-dibromobutane. This is optically active. We have a pair of enantiomers, so you get a racemic mixture. So a stereospecific reaction is one in which a particular olefin of particular stereochemistry, namely cis olefin, leads to a racemic mixture. Now instead of starting with the cis olefin, you start with the trans olefin and do the same bromination. Treat with the same bromine, you will get a meso product. What is a meso product? It is actually optically inactive. This is meso This is DL. In other words, you will find in a stereospecific reaction, you start with two different olefins. One is cis, which will give rise to a racemic product, and the other is trans, which will give rise to a meso product. The reagents are same. It is treated with bromine here, it is also treated with bromine here, but the two starting materials are different stereochemically. They are isomers, but they are stereoisomers. One is trans and the other is cis. The cis gives the racemic product and the trans gives the meso product. This is an example of a stereospecific reaction. So, to sum up, a stereoselective reaction is one in which the same starting material gives rise to two different products on the use of two different reagents. A stereospecific reaction is one in which two different starting materials are there, a common reagent is used, two different stereochemically different products are obtained.